Okay, hi there. I am Cliff Harris, or Cliffski. I am the programmer of this game production line, and I do kind of video blogs about the kind of design of that game and the progress of that game through early access. It's now on release, but I thought it would be interesting, maybe, or educational or helpful or something to do, like the odd technical programming video. So I'm just going to give you a little bit of really quick background. I've been programming since I was 11, so I've been programming for 38 years, on and off. I did have a few other little careers, so I've been doing it a long time, but I wouldn't say that I'm an expert in it. I've only ever really programmed in basic C and C++. So this game is written in C++. The engine is just for this game, and that was written by me in C++ from scratch as well. The only middleware is for the sound system. It uses DirectX, it's multi-threaded, and excuse me, I'm not used to talking. Typical coder. And I use STL, but apart from that, it's pretty much all coded from scratch. And it's developed in Microsoft Visual Studio, and this is production line. It is a car factory simulation strategy game. It's on Steam and GOG and the Humble Store and everything like that. And I'm going to try and optimize a bit of the code and just kind of like talk through what I'm looking at and what I'm doing. And I don't know, we'll see if that's interesting to anyone. I'm just going to show you what is actually slow about the game. So I'm going to go from a save game that I've got with a fairly big map, but not that big a map. So here's the map that I'm going to use to optimize. Now I should point out that the game itself is not slow. I don't get any performance complaints about the game saying that the frame rate's slow or anything like that. The only time people encounter real frame rate problems are when they have a huge map. So it would be much bigger than this. And I'll tell you why I'm not going to use one of those maps in a minute. Or they've done like a custom map where you know, they've added a load more slots and are really like pushing the engine to its limits. So what is it that ever gets slow? Well, what gets slow is pathfinding. I would say 90% of any speed related issues in the processing and running of this game is pathfinding. Now because it's like a factory sim and you've got all these conveyor belts, you might think that this is very similar to Factorio, but it isn't, because objects in this world are intelligent. So if we look at, there was a little run of them there being ordered. If you look at things going along these conveyor belts here, they do not come in at a particular slot and then go along a predefined path. What they do is you have somewhere like this called fit windows, and you can see now I've highlighted it where those items are coming from. It will say I need 5 windows, for example, or in this case, what did it need then? It needed 8 servo motors in order to fit electric windows to you know, the next few cars. So what it will do is it will say it needs a certain number of these at its stockpile. It will then find the closest locations that have them. Now you can see it's drawing from that supply stockpile and this supply stockpile. If those run out, it will start drawing them from importers like this one here, which is currently, it's importing some windows for maybe another slot, or maybe for one of these. If I click on one of these, you'll see the routes where they are getting their resources from. And we can do that with anything in the game. So what's this, aircon? It will be, there it goes, it's importing aircon from here. So what happens is that an item is created, if one does not already exist, and it is imported through probably the nearest slot to that location. If that slot's got a big kind of backlog, it will go to the next nearest one, and it will then go along these paths. I will highlight them for you by doing this. If you see these green paths here, that is basically the network of overhead conveyors that slots take. the resource items take rather. So there's a few things going on here. First of all of these little slots, they need to know where the nearest importers are, and they need to know where the nearest stockpiles are, and in some cases where the nearest slots that are actually producing those items. So it needs to do pathfinding to work out where they are, because it needs to work with this mesh of kind of connected conveyors. So we need to know it has a route to the right locations, and we need to know where the nearest location is. The other thing that happens is then when you create an object, if I pause, so I've got an item here, this servo that is imported, it then needs to follow the route to where it's going, and it needs to be able to do that even if part of that route is destroyed, in which case it needs to reroute, or it needs to adapt to other changes in the route. So if we put down a new bit of kind of connection like this, that will then change the viable routes for everyone. So it could be that one of these slots was considering that this was too far away if it was over here, but now with this new bit of connection, that route might be close enough. Thousands and thousands of these resource objects are moving all over the map right now, and if we treble the speed, even more of them will shoot all over the place. This is actually quite a small map for production line. You can get really huge maps. I'll maybe show some of the really huge ones. I mean, we're talking like 16 times the size and complexity of this. The only problem with me debugging any slowdown on something like that is when you are running in a code profiler, everything runs a lot slower because extra code is inserted to do timings. So we can do that, but you have to be very patient and just make for very interesting videos. So I don't really have a speed problem on this, but I know where the slow bits of code are. The slow bits are when we calculate the routes. Now if I do something like this, some of those objects paused there, and you'll notice that the processing, there is a very, very slight pause. Now you can barely see it because I've optimized the hell out of it for a map this size. So you don't notice, if you notice cars moving when I add something, you'll notice that there's no slowdown at all. On a big map there is, right? And on a really low spec PC there is. So this is what I need to optimize. This is what I need to fix. I don't need to, but I enjoy optimizing. I thought it might be interesting. So one of the big problems with this is if you change that layout of paths, and this could be in a real-time strategy game or anything, if you change the network of possible routes, potentially every single route in the game is invalid. Okay. The reason for that is even if that tile, which for example you deleted, if I go in and I do that, that will screw up a load of routes. But what's interesting is when you're adding a section like this, that may in fact make routes that were previously the optimum route not the optimum route because we've added a shortcut. So what you have to do is go into every single kind of route and check and say, are you now a valid route? Are you now the best route? And also, if previously I'd made a note saying I can't get from A to B, maybe now I can. So something that I may have cached, which would be an impossible route, may not now be impossible. So basically you have to junk all of the routes and start again. Now on a big map you just cannot do that, because the whole game would freeze for a few seconds and it would be very annoying and unresponsive, because I keep a huge database of every route possible. So from here to there, from here to there, from here to there, and so on. So if you had quite a small map, if you had like 200 possible locations, then you've got 200 by 200. And yeah, you could reverse them and stuff like this. But it's a huge number of routes. It's a massive number. So so what we do is we multi-thread it, and we strip out that whole list of routes that we need to calculate into groups. We split them across several cores, and therefore we can, on an 8-core PC, we can theoretically do it 8 times as fast. What we then do is delay the recalculating of those routes over maybe 30 frames. So rather than doing everything single threaded in 1 frame, when I need to recalculate all of these routes, what I'm actually doing is doing it over 30 frames and 8 cores. So it's 240 times less stress on the CPU, less stress on the frame rate rather, than it would be otherwise. So you might think, yeah, that's problem solved, but actually this is a huge programming task, a huge processing task, so there's an enormous amount to do. So first of all, where is the problem? And I'm going to show you how I find out where the problem is, and here is the software that I tend to use for that, which is called AQTime. AQTime is not very good for multi-threaded concurrency analysis, which I might show you a little bit of as well. I don't want to make this video go on for like hours, because then it just takes forever to render. Although I have stupidly fast internet now, so actually it doesn't take long at all to upload. Anyway, what I'm going to do is I'm going to run the release build, but with debugging information, with debugging symbols, version of production line through this AQTime. So I'm looking at elapsed time. There's all sorts of other ways to do it, and it is going to instrument the executable, which is basically adding a load of timing points into the code. It's now saying that all of these functions have been optimized away, and they're like little get and set functions that the compiler has kind of inlined, but I don't care because I know that they're not my slowdown anyway. So here we are, the game is running. I'm gonna quickly get into was it this one? I can't remember now. And I'm just gonna run it a bit, and I'm gonna force it to do some recalculating of routes. Now it did it anyway when we loaded there. You'll notice that the game is running slow. Look at that rubbish frame rate. That is because we have all this background stuff going on to profile it. Now if I change these routes now, that would have caused a huge amount of recalculating. So does that, and that, and that, and also this. And now I'm going to stick in one of these, and I'm just going to fill it with I don't care what. And then I'm going to go fast forward and get as much stuff done as possible. So loads of routes have been calculated, and the main thing that I want to do is a low-level optimization. I'm not looking to do an algorithmic optimization as such, because I've done a lot of that, and hopefully sorted out a lot of that stuff. So that'll do, and now I'll quit. That was a little snapshot because I'm making a video. Right, so there we go. So now I've got all this this data on what went on. And these are all of the functions in the game here on the left. I'm looking at all threads. You can just look at an individual thread, which is interesting if you want to look at the base thread, because the base thread is ultimately the one that's going to block you. But I'm going to look at all threads because I know what I'm looking for. Okay, and what I'm looking for is the pathfinding stuff. So I think, because I name my functions and classes roughly sensibly, if I go down to sim, I think it's called sim pathfinder, probably is. Sim pathfinder, evaluate from tar, blah blah blah. I know it's from that generate path. Right, okay, so if I look at generate path, if I look over here, I presume you can read this, I don't know. But that is only 0.02% of all time, okay, in the game, which you sort of think, oh, that's not a lot. But we're not actually capturing everything because of the way threads work. So if I actually do that, you'll find it is actually fairly high up. If I'd let the game run for longer, then then this would all change. Basically, I know that generate path is on big maps slow. So this is sim underscore pathfinder generate path, and the way this is laid out is quite interesting. So here, this is what called this. So find path and is still impossible called this function, and this is what this function calls. And I really love this view of it. So here we've got 73% of the time was spent in evaluate from tile, 14% was spent in get best open tile. Now, the pathfinding system that we use is called A star, and it is, you basically kind of like start from the beginning and you flood outwards from your location through all these other tiles, and at each one you make a guess of how far away the target is, and you have like an open list of tiles that you think might be the most sensible next tile, and then you have the closed list of ones that are not, and you go through all possible tiles until you actually kind of like hit the target, and then you kind of stitch the actual route together backwards after the event. I then have to do some other things in there as well in order to kind of make it work. I'm using a jump point search, which is an optimization of A star, but basically it's, you know, it's your basic A stars. So your two kind of core loops in the A star are evaluate from tile and get best open tile. If I click on that, it will show me anything that I maybe call, and the same with get best open tile. Now they're pretty empty, and what I can do is I can actually, somewhere down here, I can look at the editor and I can actually look at the code, which is interesting, but to be honest, I can just look at the code here, where I've got all my syntax highlighting and stuff like that. What I'll do in a minute is I'll go into far greater granularity to show you how this can actually be helpful. But if I go back and I look at find path, what's going on in find path, sorry, generate path, blah blah blah. So it's mostly evaluate from tile, and it's partly get best open tile. But basically I'm looking at Sim Pathfinder as a class that is too slow. So this doesn't help me that much yet. I kind of already knew all this. Okay, so what I'm going to do, I'm going to go into setup, and I create a new profiling area, which I will call Pathfinder, but it doesn't, who cares? And I'm going to say collect info about lines. This makes everything a lot slower, but I'm going to do some magic sauce, because I'm going to put that one class in there, and then I'm going to run it again. So blah blah blah, yep, run it. So what we're doing now is I'm doing exactly the same thing, but I'm only bothering to profile a tiny part of the game, the pathfinding code. So nothing else. Oh, look how slow it is. Look, we've got to calculating nearest bays, and that big slowdown there, because I pre-populate this whole database of stuff, that was calculating that. You see that? See that there? You get an immediate slowdown, and then you get your 30 frames of the seat. There, we're back to normal, of every core going bananas. If you watch it again, pause, oh, and then different threads working, and now we're back. That's how slow it is. If you've got, like, you know, 16 times the size of this, and everything's going at triple speed and all the rest of it. So and let's delete something. That will also cause problems. I don't think there's many, but I'm adding things here and I'm deleting things, and oh my god, lots of paths being generated. I'll let it get back to normal, and then we'll quit out and we'll take a look at what's going on. Okay. So now I'll have a lot less data, but it'll be relevant data. Here we go, we haven't got a lot, have we? It looks rubbish. So again, here we are. I don't know why the formatting goes wrong there. That's a bit silly. So blah, blah, blah. We're back in generate path. Okay. And again, we know evaluate from tile is 71% of the problem. Get best open tile is 27% of the problem. Now if I jump in here, again, it's absolutely no help until I do this lines, which tells me what line of code is slow. And sometimes this screws up, but hey, it works. So here's some code. Let's look at some proper code. So evaluate from tile. Okay, this is where we're kind of like working out the core of the route. So I'm going to explain this function, and then we'll look at the kind of damage that it does. So basically, I come in here with a little data structure, sympath data, and that is basically saying, okay, we've got this file, where do we go from here? And so that is p data. So where we're starting from is p data, p tile, and we've already got a value of how long it took to get here, which is g. So if root type equals p resource and b jump point, and it is, this is only for other stuff like when we're placing down car conveyors, which is super fast, and we don't do it a lot. So this is the slow bit here. They're kind of the same anyway, it's just a little enum. So what we're doing is we're saying, for this tile, get the tile on the southeast, and then maybe consider adding that to the open list. Same with southwest, northeast, northwest. We can't go diagonally, we can only go in those 4 directions. So we're basically calling make maybe open tile 4 times, and we're calling get conveyor at facing 4 times. What happens then? Down here, we basically have to put well, I mean, we've actually got a comment. We have evaluated this tile, so it now goes on the closed list. So what we're going to do is add something to the closed list, and we're going to remove it. Be removed equal true if blah 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 blah. Be removed equals false. Oh my god, look. We have something there that is irrelevant, and it looks like the compiler is... No, it's still wasting time. So basically what I'm doing there is I'm going through the whole array of open tiles. Oh, that's why I've got a little exclusion there. So I'm going through this whole array of open tiles and trying to find one of them that matches where I am now. And if so, I'm going to set that to null. Now, I don't have an open list. If you've programmed A* from scratch, you'll have an open list. But lists are really slow and arrays are super fast. Okay, so I actually have an array where rather than removing it from the list, I will set it to null. It's a long story. But basically all of that together is like 9, 10, 11, 12, 13, 14, 15% of this function is going on that. And then blah, 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 p closed matrix. Again, I don't, I'm not using lists. Lists are slow. If you can avoid not using a list, then that's good. And this is really performance file code. So I've got another hack here. I have this sort of what looks like a huge array here. You can see me getting the index point into the array. I've basically got an array of every single tile on the map. Okay, a 2-dimensional array. Although I've flattened it out so it's not 2-dimensional. And I'm basically setting it to be true if it's closed. That's actually a lot quicker than adding stuff to a list and removing stuff from a list when I may do that thousands of times. Okay, so this is quicker, and that's why I'm doing it that way. So all of this 9, 10, 11, 12, 13, 14, 15, 16, 17, 18% is the whole kind of like list management side of the function. So obviously the majority of it is here, right? We've got a little bit of function overhead there, 0.89% to actually come in here, and like 1% to sort of close it out. So most of it is maybe add open, right? Maybe add open, whatever that is pretty slow. If I look up here, I can see evaluate from tiles, so 19% to 12%. So like 13 out of my 19%. Is that showing up? This is Chris from Introversion joking about my Tesla stock. Anyway, ignore that for now. So maybe add open. Okay, so this is like a big part of it, right? This is where we can get some saves, or so we think. So what does this actually do? Well, we are like a resource thing. So we come in here, maybe add open. And first of all, we need to work out if that is a tile. So what we try and do is we try and get a conveyor pointer from that tile. If there isn't a resource conveyor on that tile, we don't care. We know not to go there. So that's just saying whether or not we're a valid tile. So, you know, who cares about that? Because that's 3% of this function. Right, so, you know, kind of who cares? that switch statement there itself uses up a non-trivial percentage. Anyway, so we go down here. So let's assume it is a valid tile. Otherwise, we've jumped out. We need to check whether or not it's locked. If it's locked, it's in part of the map that the player can't use yet. Arguably, we don't need that. Here's a potential optimization. Arguably, I don't need that if there is a conveyor there, because there's no way for the player to put down a resource conveyor on a locked tile. Arguably, I could skip that and speed that up a bit. And if this says here, if it's office space, false. Again, you can't put the conveyor over the office. So that is, this whole section of code here is irrelevant in this instance. So we might be able to speed things up here. If I go down to if be valid tile, now this is where it gets interesting. Look, this is where it's all going, right? If we look at the real big problems in this function, they're all here. So here we go. When we look at that top open array, if we look at this open array here, we're going through the whole lot, okay, and seeing if it's this tile. This is basically a way of saying, is this already on the open list? And if it is, then return. And the interesting thing is, look, that never triggers. That never happens. Which is interesting in itself. We've then got 4% on getting the jump distance, which is part of jump point search. To be honest, I really don't care how much this takes, because it speeds the whole thing up so much that it's kind of like a free win. So all we're really doing there is 2 calls to like abs. And that's 4.4%. This debug stuff isn't even run, so that's fine. Then we've got some really, really simple stuff where it says here, data manager create object. That's a factory. It's not really creating an object, so it's just reusing an object that already exists and I know is blank, and I'm then setting some values on it. I mean, that's a simple pointer assignment. This is the level that we're at. So any of these things here, these are very, very simple assignments. It's interesting that abs and abs there is only 1.5%, whereas here that's 4.4%. I wonder why that is. I wonder why that is. That could just be an anomaly of the run, I guess. And then when we get here, we've got the same thing, that we've got this huge array that we're going through. So blah blah blah. So we go through all of this stuff. It's just iterating. It takes forever. If not open array I equals p data. So this is basically saying add it to the list, right? If not open array I blah 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 be added equal to. Should we stop when we get here? So we're going to do a lot of calls to this. You can see the hit count here, yeah? So we ran this line of code 4 million times. We ran that line of code 9 million times. Which is basically we're running it 10 times for each go through this function, because you can see here the one before, 820,000. So we're only really getting up to 10 here. So I never goes really above 10 on average. So it's hard to see that there's any way to speed that up. But there must be. There must be a way to speed that up. And this thing here, you know, we're only calling once when we actually sort of find a free slot and we place something there. Debug assert doesn't actually get called. If it's debug assert, it's getting compiled out, so it would never happen. Same with that. So herein lies the problem. I think I might stop the video in a minute, and I might do another one, because I need to speed this up. Okay, and the question is, like, I have all the data that I need here. Look at that. That's 11,780,000. So we're only we're only really going up. This open array stuff. We're just going through a tiny array. Is there any way to make that quicker? Or have we reached the limits of what can be done? If you're watching this and pulling your hair out and going, Cliff, you idiot, there's a really obvious optimization here. You know, put it in the comments. Firstly, because it helps me. Secondly, because everyone would be interested, I think. And sometimes you can squeeze on an area and realize that there's just no, you know, there's a big solution somewhere else. But it's not here. This here, p evaluate, get conveyor at facing, that's literally returning a pointer that's been precached somewhere else. There's no optimizing that. That is a function call, but it's kind of been optimized away. Oh, by the way, if you're really into it, you can look at the assembly language in AQ time. I don't really know assembly language very well, but there, if you look get conveyor at facing, there's not a lot of instructions being called here. I'm not sure how you could possibly, and look there, it's managing to do it in one. So yeah, I don't think there's much kind of optimization that can be done there. Whereas if we go down here, like, how bad is it? Maybe add open if we go into the disassembler. Is there anything like massive here? Is there anything that comes out into a huge number of instructions? Not really. Not really. Maybe, you know, this stuff we're not calling much anyway. So this is my current dilemma. Anyway, I'm going to stop this video here. I might do a little bit of poking around and then do another video which I'll put up another day. But this is the kind of stuff that I wouldn't say keeps me awake at night, but it annoys me because it must be possible to make this faster. Why does that take so long when it's only going up for int I equals 0, I less than equal, let's say 10, right? Let's say 12, I plus plus. There's no way to speed that up. Yet how can it take such a big chunk of this? Have I reached the limit? Anyway, this is what it's like to program all day. If you're not a coder and you're watching this anyway, if this looks awful and you think you want to do low-level C++ programming or whatever, this is what it's like. Anyway, this is trying to optimize the pathfinding in production line. Hardly anyone will find this interesting, but I don't know. I would have before I knew how to profile. So subscribe to the channel if you want to know when I do any more of these. I might do a few more. I don't know. There must be a way of making this quicker. Anyway, thank you for watching, and I'll probably do some more. Stop.